Guys, now we are back. I am going to try to do this exercise in Kaggle. It's transfer learning. So, transfer learning is part of the deep learning exercise. I think it's exercise number 5 or 6, something like that. So, the idea of transfer learning basically it's um, you have a deep neural network, right? So if you already understand what is a deep neural network, more or less, basically is there's many layers, right? And each of those layer basically abstracting some sort of representations of the image or the data that you're putting in, right? And the deeper the layer, the more deeper the layer, or the actual the last layer compared to the earlier layer would be more and more uh, sort of representations of that image in a compressed manner. I That's the way I see it, at least. You might not agree with the words I'm using. So the idea of transfer learning is basically instead of if you already let's say train a model for let's say and then there are 50 layers, deep neural networks, 50 layers. Let's say you're training to identify whether it's a cat or not a cat or a hot dog or not a hot dog. Hey, by the way, guys, if you haven't seen that movie, what's Crazy Rich Asians movie? That's amazing movie. The guy, what's the Asian funny guy? I forgot his name. Is from Hong Kong, but he doing a sitcom in Silicon Valley. He was there. He was one of the crazy guys there. It was funny. Anyway, the whole movie was funny. Um, so okay, going back to the deep neural network, right? So basically, if you have a lot of layers and you already train it to identify a certain use case, and you want to identify, for example, you already identified to, let's say, for cat or not a cat, and then you want to identify different use case, for example, dog or not a hot dog. So instead of redo the whole training again from the beginning, from scratch, which is supposed to be expensive and time consuming, and not to mention um, you better spend your uh, things somewhere else, right? And it's not efficient. So the idea is just to take the whole pre-trained model that you already see is successful, right? And then just change the last layer. So if the last layer is identify hot dog or not a hot dog, you just scratch that and then put in a different layer, a new layer, and then you still keep if it's say like there's 100 layers, so you keep the first 99 layers intact, right? And then you can retrain the model without doing it all over again. So that's the idea of transfer learning, right? Um, so here we go. So here the exercise is doing we're supposed to help a cameraman. He was shot deep learning videos mention a frustrating problem that it could solve using deep learning. So he has a service that scans basically a photograph and store them digitally, and he used a machine that quickly scans many photos, right? But depending on the orientation of the original photo, many images are digitized sideways. So he currently spends a lot of time looking to find which photos need to be rotated sideways, right? So he can fix them. So we are trying to use machine learning or use deep learning to automate this process to identify photos that are sideways um, and which are upright, right? Instead of him doing it manually, we can help him, right? So probably at the end of the day, we can just have two folders. One is upright and one is sideways, so he can work faster. So we need to build a model to identify to distinguish these two photos, sideways and upright. So two classifications, right? Quite simple. If you are going to sell this service commercially, you might use a large dataset to train the model, but will have great success with even a small dataset. We'll work with a small dataset of dog pictures, half of which are rotated sideways. Okay, so we'll look at the dog pictures. Specifying and compiling the model look the same as in the example you've seen, but you'll need to make some changes to fit the model. Okay. Okay, since this is your first time, you won't be able to create this from scratch. You have filled in most of the code you'll need, but left some critical pieces blank. Okay. Fill in the blanks, mark with dash 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 4 times in the code below, and then uncomment those lines and run the cell. Okay. So from TensorFlow, blah blah blah, you import the ResNet. This is the model basically, the pre-trained model, right? It's ResNet 50, and then import sequential. This is a type of model. Basically, sequential is like a feed-forward network, kind of, right? Um, and then you want to import the dense, flat, global average pooling 2D, right? Dense is like every neurons is connected to the neurons before that. Flatten, I'm not sure about this. What flatten is? Global average pooling 2D. I think this is about making it average if you happen to in the future create a different layer and then you just want to put additional neurons so it make it like easier some so to speak. Anyway, so number of classes is the number of categories your model chooses between each prediction. Okay, ResNet. What is the number of classes? I don't know. ResNet weight. Okay, so I guess I have to get that out, the hashtag out, and then my new model at ResNet include or false. Get that out, and then get this one, my new model at dense activation softmax. The value below is either true or false. If you choose the wrong answer, your modeling result won't be very good. Recall whether the first layer should be trained, change or not. My new model is trainable. Huh. Let me see. What should I put here? Number of classes. This is the number of categories your model chooses between each prediction. It's two, right? Is it two? There are two classes, which is sideways or upright. This is the value true or false, which is wrong. Layer 0 trainable. So remember, transfer transfer learning is about learning. Sorry, about only training the last layer, right? So you want the layer 0 to be false. You don't want to train that. Yeah, and then you get rid of the hashtag, and then we run this and see. Hopefully, it will work. It will take some time. And the only thing I don't like about this Kaggle, everything is nice, it's already like provided the GPU, the Jupyter Notebook, the right like Python version and everything, all the dependency, the Keras, the whatever if you need to use NumPy or other dependencies. But sometimes it takes quite a long time to fork it. For me, probably it takes like I don't know 2 or 3 minutes, but I think it's simpler. It's just my feeling is just there's many people who wants to use this framework. I mean this service. So and it's free. Um, okay. Let's run that one. Take some time. It's still an asterisk here, still running. Well, my laptop is quite hot. Okay, so it's done. Recall whether the first layer should be trained, changed or not. So it's false. Now it's compiling the model. We are again provided most of the code and left one extremely important piece blank. Fill in the blank, then uncomment that line of can run cell. Okay, we are calling the compile command for some Python project. Which Python object is being compiled? Fill in the answers to the compile command works. Which Python object? Um, my new model, I think. You need to compile that, right? Which Python object is the model has compiling means optimization. Remember, deep neural network works by basically putting all the images, right, and then summing, multiplying uh, all of the weighted inputs and summing it all together, and then apply activation function for non-linearity, right? And then at the end, at the last layer you want to put after you put all of the inputs from the previous neurons, and then you weighted all of the inputs and then summing it all up again, just like you do on the previous layer. You want to do a softmax. Softmax with basically the outputs, because the output is you want the output to become a probability from 0 to 1. So that's what the softmax does basically, right? And then after you got that probability, you want to minimize the error. So minimizing the error and back propagate to fine tune the weights and the parameters, the hyperparameters, basically the weights and the biases. That's called optimizing in this case, right? So the model that you want to optimize is basically the model that you already built on the previous here, right? Previous session on the in this Jupyter notebook, which is the Manu model. You already put like a, a sequential. You put the model is a ResNet 50, and then the top include top is false. Basically, this one you don't include the top layer. Remember, it's transfer learning. You don't want to include the last layer. Pulling average. The weights is a ResNet weight path, right? So you want to optimize this. So I think that's the answer. So my new model, right? Boom, run it, and then you're using a stochastic gradient descent. It's a kind of algorithm for optimizing. Um, Basically, when you do back propagation, you are using a gradient descent to find the direction and how much steps do you have to adjust to your weight and biases, so that the output would be slightly better or a little bit better or much better. So depending on the derivative, basically that's how you define how much. It's depending on the derivative of the output over the input, right? So um, one of the algorithm to use that is called stochastic gradient descent. I think stochastic mean let's see what's stochastic gradient descent. Stochastic gradient descent. I think it's more like a random um, incremental gradient descent, iterative method for optimizing a differential objective. Okay, it's called so stochastic gradient descent versus gradient descent. What's the difference? So batch gradient design computes the gradient using the whole data set, using a single sample. Okay. Yeah, let's look at the code right here. Mm-hmm. Ooh, this looks so complicated. What the hell, man? Mm. Okay, gradient design is computing based on the complete training set. Okay, we call it batch. Okay. Ah, okay, based on complete training set. Single step for one pass. Okay. Okay, so you don't use the whole training set. True. Approximation. Stochastic. Okay, so it doesn't use the whole training set. You have to run you have to run through all the samples in your training set to do. Okay, only one or subset of the training sample. Okay. Stochastic often converges much faster compared to GD, but the error function is not well minimized. Okay, cool. Okay, okay. Have we run that? Have we run this? Let's run this again. Boom. I think we ran that. Yeah, 4. Okay, now we are into the fit model, right? So basically after the compilation, I think the model is already being optimized, which means the parameters, which is the weights and the bias, is already being set and s- up set properly. So the hyperparameter has been kind of optimized, right? Whether it's like point 0.2, point 0.3, point 0.3564, or all the numbers already being set. All the knobs and dials has been turned. So now it's time to train the data, which is it's called fit model. So the training data is in this directory, okay? Images dot slash train. The validation data is over here in this directory. Use that information when setting train generator and validation generator. You have 222 images of training data and 217 validation. For the training generator, choose a batch size of 10. Oh, batch size of 10. Figure out the appropriate values, steps per epoch in your fit generator call. It isn't the same as in your example. Fill in all the blanks again, Mark. Then uncomment is run. Watch as the model trains the weight and accuracy improve. Okay. So, okay, from the ResNet 50, you have to import preprocess. And then, so before you can even actually train the data, the training input, the input to the model, to fit the model, you need to pre-process the input, basically. Okay, so you need to import all of this function, basically. Image data generator, image size 224. Okay. Um, okay, I have to take this hashtag, and then I think I'm gonna put this directory right over here. So I just copy this And I'm just gonna put it here, I think. There you go. Done. Because that's the training data. I put it into the train generator here. Variable. Um, uh, Remove the hashtag of this target size, which is the image size 2024. 2024. The batch size is, I don't know what the batch size is. Just batch size of 10. I don't know what does it mean. Like every, okay. So every batch has 10 images. Is that what it means? Okay. Then class model is categorical. Yeah, I'm not sure what this. Now the validation generator. Okay. I have to copy this, I think. Do I have to put the comma there? I think so, right? I have to put the quote, right? I cannot just equals this thing. I think I have to include this, right? This one. Yeah. Okay. We'll see. If it doesn't work, then we'll try to fix that. Clean that hashtag on the target size. Clean this hashtag to class mode categorical. Now it's time to put it into the fit to the model to fit it, to train it. Um, Take this out, the train generator. Steps per epoch. This one I'm not sure. What is steps per epoch? Huh. I don't know what's the steps per epoch. I have to like cheat for a while. This the steps per epoch is 3. Hmm. I don't know why it's 3. The bed size is 24. Okay, I'm gonna see. Let's see. Hmm. Okay, steps per epoch is 6 because it says what do you say? 12 images at a time. Okay. Because 12 images of a time because the batch is 12. The batch size is 12. Is that it? And we have 72 images. Okay. Okay. And this one, okay. Is that how it works? 72 divided by 12 is 6. Really 6? The batch size is, where is the batch size here? Hmm. Oh yeah. Okay. The batch size is 12. Okay. Got it. And then there's 72 images. Where's the 72 images? Image size. Oh, the image size, you mean? The um okay. It's it under data generator. Okay, let me see. It doesn't say here. Okay, okay. So I guess the steps per epoch is basically image size. This one 224 divided by batch size 10, which is about 22. Okay, we'll see. Let's put 22. Um, validation data equals to, I don't know. What is validation data? What is validation data? Oh, it's equal validation generator. Okay, okay, got it. Okay, it's basically it refers to that file. Okay, this is one of the parameter. The validation data is has to be validation generator because the validation generator is basically it's a variable pointing to the all of these things, right? Which is the pointing to the validation uh, training. I mean, sorry, the validation images on this folder, right? With this image size 224, 24. Got it, got it. Okay, let's see. Yeah, I think we're good. I'm pretty confident this will run. The validation steps is one. Huh. Let me see. Wait. What? Hmm. Validation reach generate 20 images at a time and really? Okay. How many? This is one. Okay. Okay. Let's run this. Oh no. Invalid syntax. Hmm. I don't know why invalid syntax. Probably. Do you know why is it invalid syntax? It looks good to me. Input urban, rural photos, rural and urban photos. Let's see about the ducks got sideways. Images, train. Hmm. I think there's something wrong with the data because if you look at the data, it's correct input slash docs colon sideways here, but there is no folder for images. Well, there's images, but that's it. There is no train and validation. Hmm. Okay. I think that's why it's wrong. It's invalid. Yeah. Upload data set. Yeah. If you look at this one, it's working because it's really as you look at it. If you look at it's divided by rural and urban. So in let's say for example this one, yeah. Input urban rural photos, which is this one, and then rural urban photos, this one, and then you go to train or val, right? Train, and then and then there is a rural and urban, yeah, correct. Train. Okay, okay, yeah, there is that directory. All right. So if I run this, What's wrong with this? Should I okay, 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 okay. Okay, I'll run it again. That's not 50. Come on. Come on. Come on. It's been too long. Okay. Now compile. Yes. And then now the fit. What? Object not image data generator. There's no attribute image data generator. Hmm. Why it doesn't work? Why it doesn't work? Oh my gosh. I don't know. I don't know why it doesn't work. Is this normal? But it says found 72 images belonging to two classes. Found 20 images belonging to two classes. Okay. Hmm. Yeah, it doesn't work. I don't know why. Okay, guys, I'm not sure why it's not working. I think it has to do with this. The folder is incorrect because this one is looking for folder images slash train, right? Well, if you go here, it's just images. There's no slash train folder there. So yeah, I think I don't know why. It's I think they give us the wrong. Um, I'm just gonna go to the forum and then tell them. I think it's they give us the wrong um, input. It's so slow. Oh, come on, come on, come on, come on, Dan, come on. Transfer learning. Let's see. Uh-oh, low battery. Deep learning using overfitting. The machine learning. Okay, I'll just say transfer learning exercise 6. Yeah, exercise. Hello. Looks like the data input is for training class validation is not correct. Um, say, say best that is available on the Kaggle kernel, but in the code it is looking for class train. Thank you, Danny. Okay, this is published topic. All right, sorry guys.